Hi, Mrs. Moret here with help on today's assignment from Unit 4, Lesson 12. So today you learned about E, which is the natural base, and approximately 2.7, and then some. So I'm actually going to use the calculator a little bit and the Desmos app a little bit for some of these problems. So first, put the following expressions in order from least to greatest. And so obviously there's some of these that I kind of know and some of them that I might use a calculator. But let's think about this. So if I have e to the third versus e to the second versus e to the e, okay? So e to the third versus e to the second, e to the e. So out of those three, e to the second would be the smallest because its exponent is 2, whereas the next, oh, sorry, my camera froze there. Hold on. Okay, so e to the second would be the smallest because the exponent is 2. And then between e to the third and e to the e, well, on the last one, the exponent is 2.7 something, which is smaller than 3. So I know these three would kind of go in this order. And then I have to figure out between 2 to the second and 2 times e, where they would go. So 2 to the second, I know is smaller than e to the second because 2 is smaller than e. So I know 2 to the second goes below that. And then 2 times e. So I want to think of this as 2 to the second, 2 times 2, where this is 2 times e. And since, again, e is a larger value than 2, this would be the smallest, and then this would come after it. This would also be smaller than e to the second. E to the second is e times e. 2 times e would be less than that because, again, 2 is less than e. And so 2 times e would go here, and then 2 squared would be the first one. Okay, so that is how these go in order from least to greatest. On number 2, we have graphs of 3 functions, and I know in an exponential function that its graph is going to grow more quickly the larger the base of the exponent. So those all have the same exponent of x. F of x is 2 to the x, g of x is e to the x, and h of x is 3 to the x. So what I can tell is that 3 to the x, that has the largest base, and so it's going to grow the quickest. So this would be h here, this first one. And then the one in the middle would be g because e, which is about 2.7, is between 2 and 3 in value. So this would be graph of function g. And then the one that grows the slowest would be the one with the smallest base, which is function f. On number 3, it says to select all the statements that are true about this function. F of x equals 100 times e to the negative x. And so I chose to graph this in Desmos to be able to kind of use the graph to determine which statements are true. So to graph this in Desmos, you just type the letter E here, and it already knows what I'm talking about. It knows that I'm talking about the natural base. And so this is what the graph looks like. And make it a little bit bigger. Okay, so let's determine using this graph of the function given which of those statements are true. So the first one is the y-intercept of the graph of f is at 0, 100. And I can see right there, yes, that one is true. That is true. I'm going to circle A. The values of f increase when x increases. Well, No, it's clearly decreasing, so not B. C, the value of f when x is -1 is a little less than 40. And I know -1 is over here, and it's actually going to be more than 100 because it's 100 when x is 0. So it's actually up here, not a little less than 40. The value of f when x is 5 is less than 1. It kind of looks that way, and when I hold this down, I can see it's a decimal. Let's see here if I can get, it's kind of hard to like not have my hand be in the way, but see how it's like a decimal less than 1. So it's less than 1. Yes, that's true. And then E, the value of f is never 0. And that's actually also a true statement. Remember how these exponents, they just approach that axis but never actually get there. It looks like it does, but if we zoom way in, my gosh, like forever and ever, zooming in might just be a waste of time. But eventually, we would be able to see that this remains slightly above. I think I did too much on my screen now. It doesn't like me, but this line remains slightly above 0. So the value of f is actually never 0. So E is also true. All right, moving on